I'm back. Stupid connection, lost connection again. So everybody come back. Hopefully it will stay, I can stay connected. And hopefully you guys got to hear all the stuff that I was talking about. Otherwise, I was just talking to myself, which is, you know, I do it a lot, but it's not nearly as fun as when everybody else is here. But the ring gap, as tight, I cannot believe how. And if you, for you guys joining, hopefully you watched part 1 where we talked about the ring gap being very, very tight on the GM LS3 base CT525 crate motor that I was doing for Finnegan. When we took it apart, when we finally did take it apart after testing it without checking the ring gap, it was 13 thousandths. So that's really, really, really tight. That's really marginal for even for even kind of high performance NA use. That's tighter than I would run on anything. There's just no reason for it to be that tight. Yeah, everyone's coming back. There's no reason for it to be that tight. You should want more than that. I mean, you should want you know, at least I would like to go 5 or so on an NA motor per inch of bore. So, you know, it should be more than that. But I know the factory likes them tight. You know, they don't want obviously any blow by. It's better for emissions. And so there's a lot of reasons that they do it. And I just don't think it should be anywhere near that tight. So we moved it out to, you know, into the safe range, 27, 28. So hopefully Mike doesn't have any problems and it will all work out just fine. Yep, I'm back in the house. Hopefully, I don't know why the connection here is just terrible. But I am back from West Tech, so I got all of that testing done. We as you guys saw, tried to run the 6-liter, and that didn't work out. But it turns out I think that was just belt slippage, which we'll try again and see if we can cure that. I'm going to route the belt differently on the next time out, and we will try using a new belt that's shorter. We'll try a couple of different things. So let me know out there what you guys have done. What kind of, have you guys run, you know, unopened motors from the wrecking yard? Have you guys had success with doing that? Have you had failures doing that? Because I know that it goes both ways. I've seen plenty of people ruin motors without adding ring gap to it, and I just like doing it because it's a good idea. Even though I had to spend, you know, the better, you know, whole nother day basically getting it ready, because it takes a long time. And I even got to use, which is cool, and it makes life so much easier. The guys at West Tech have, you know, good tools necessary to do it. They have from Total Seal, they have the ring square tool. They have an electric ring grinder. They have the right size ring compressor. So all of that stuff made life, you know, a lot faster. But still, you have to, you know, I had to take the head studs out of the old motor. So we have to disassemble that to get those head studs out. You got to make sure that we clean them all, that they're prepped properly. You have to clean the heads. You have to get all the surfaces dry to put the washers on. And so there's quite a bit of prep. You know, it's all in the preparation to make sure that it's done right and it's going to work well, and that hopefully the thing goes out and makes power. And if it goes out and works well at the power level that we ran it at, which is basically just on the gate, and Mike's able to go out and make passes in it and everything's working, then hopefully he can even turn it up, which will be kind of cool. Wrecking KD, I've run gapless rings. I've never run them on a boosted motor before, though. Jeff said he's had good luck with an 18 ring gap and a 200 shot of nitros. We did run a 300 shot on a motor from the wrecking yard that we never opened up. So I never ended up opening it up. So I don't know what it was, but whatever it was, it worked fairly well. Yeah, Adrian, if the motor's out of the car, it makes it obviously it's a lot easier to work on the motor. If you've gotten something from the wrecking yard, it's on a stand, it's a lot easier to work on that. It's a lot harder to do it with the thing in the car. I have somebody that would do that to the Nova, put the new floor pieces in. They're going to have to weld that because I'm not qualified to do that. Yeah, I go 7.5 thousandths per inch of bore on these things. Frank, that's good. A junkyard Toyota, a 4AG. I like those motors. I like those little twin cam motors. 15 pounds. That's good. So let me ask you guys this: on the ring gap thing, we're running Eric and Ish did the tuning on it. They ran it very conservative at like 14 degrees or something like that at the top. Having less timing tends to increase exhaust gas temperature. So will that make the thing less or more likely to detonate or less likely to detonate? I've always wondered about that, because having the right timing in it, if you have enough octane, the thing sounds so much happier and the EGTs are much lower. But do we get to a point where taking timing away to eliminate detonation can increase detonation? Like, total seal rings, Tim. Rob Zilla Garage, the ring gap, if you increase the ring gap too much, it can increase blow by. But in the ranges that we've done it, I didn't see a big change in blow by. Yeah, Andy, that would be a lot of work to find out how much too much is. What you'd have to do is run it at 27 or 20. That way you don't have to do it twice, or you'd have to do one ring gap swap. Then you go, okay, yeah, 50 is too much. So somewhere in there is the okay range. See, Bill, I don't have a feel for that. I don't know. That's what I was asking about the exhaust gas temperature, because I know that that's going to affect that can affect the detonation threshold also. But the butting the ring is temperature. It's ring temperature. So as the ring expands, then it butts together and breaks the piston. I don't know that. I honestly don't know. Ignition timing, lowering ignition timing may make things worse. Lowering ignition timing can also change the detonation threshold, but the detonation threshold is different than what we're talking about with what the ring gap is changing. Gas porting the piston rings, could you increase timing? I don't know that will have an effect. Usually gas porting them is going to change the you change the tension on the ring, and then you gas port them so that they have more pressure on them so that they seal better. But I don't know that that's going to affect what we're talking about. Yeah, Mike, I'm going to start making a schedule and do promos, and we're going to make it a little more professional rather than just a casual approach that I've been taking. Yeah, 30, Justin, 30 works fine for the top and the bottom, and 28 will even work. And honestly, it may work lower than that. I just have never tested real high horsepower stuff at lower numbers than that. We haven't, and see, Frank, that's another thing. I didn't run any ring gap yet in the K24, and we were running it at what I thought was a very safe level in terms of timing and E85 and intercooling and boost level. And I don't, and now there's no blow by in the motor. The motor's perfectly happy. But now it makes me wonder how far you can go on the stock stuff. Yep, sharp edges in the combustion chamber, the shape of the combustion chamber, the shape of the piston, sharp edges on the piston and the valve release. All of those things can change the detonation threshold. Are there any rings with the lower thermal coefficient? Yeah, there could be. There are definitely different ring material, and so the growth rate of that material will change based on whatever the material properties are. I'd have to ask one of the ring guys if they have some sort of matrix for that to find out what the growth versus temperature is of the different style rings. Rotary, we're going to do the same thing. It's going to be about 7 or 7.5 thousandths per inch of bore on the on the 4200. And that brings up another good point. I wanted to give you guys an update on that. I actually put that motor in my truck and dropped it off with Jason at JT Fab, and he's doing a turbo manifold on it. Even though I'm going to run the stock exhaust manifold first with a turbo, he's also doing, you know, a double wazoo kind of racy, you know, sexy kind of turbo header for it. So that'll be cool also. Tracy, you should still do like 28 thousandths on that. And we go 30 if it's going to be a real high boost. Thomas, if you get a high mileage 5.3 from the wrecking yard, there's no guarantee that the rings will be already opened up. I've run dozens and dozens of those motors, and we've taken lots of them apart, and there didn't seem to be a correlation actually between mileage and ring gap. We had some that were like really, really tight, and we had some that had less miles on them that were really opened up. So there's something else going on there that I can't understand. You would think that that would be a direct correlation, that the longer that they run, the more ring gap because they would wear, but that wasn't the case. All right, Mike, take it easy, man. Yeah, and anywhere in the safe range, and a lot of the stuff that I did for the Big Bang was over 30. Some of them were probably closer to 35, because I wasn't really exact about what I was doing. There was a go no go kind of thing. It's going to be at least 30, so we laid into some of them. Yeah, I actually tried heating the ring up with a torch in the cylinder, but the cylinder was taking away all the heat basically to make it a structured thing. The thing that I don't know is I don't know how much temperature is in the cylinder and the growth rate of the cylinder versus what's happening with the ring. So I don't know. I'd have to ask somebody that's much smarter than I am about that. Like, does the ring grow more when we put temperature in it than the cylinder does? So that, you know, relatively speaking, the gap reduces even though the cylinder is growing a little bit, because we have different materials and we have different amounts of material, so different mass of the same. Even if we have the same material, we have different thicknesses and stuff. So there's a lot of things going on there. Aaron, I think 24 would be safe. Justin says I pulled a Gen 4 apart, which is what this aluminum one was, with 290,000 miles and at 12,000. See, that tight stuff just scares me. That scares me for an NA, for loading an NA motor for a long period of time with 12 thousandths ring gap. Does kind of scare me. Yeah, and Arthur brought up a good point. He said he has an 07 L92 with 186,000 on it, and he took it apart and had 16 thousandths ring gap, and he opened it up. Here's the thing about unopened versus gapping rings is that when you go get a motor from the wrecking yard, you don't know what the gap is. You can say, yeah, it's got 200,000 miles on it. It's probably open. Yeah, it's probably open, but you don't really know that that's the case until you open it up and check it. It might be a lot. It might be a little. It might be like this 12 or 13 thing, which is almost certainly going to break. Now, a lot of guys are willing to take a chance. They don't want to take the motor apart. They put it in, they run it, boost on it. If it all works out good, that's fine. The other thing that ring gap I think does is gives you a little bit more leeway in the tune also. So you can miss the tune by a little bit and then go, oh yeah, I need to adjust that. But I didn't break it on that time when I made the mistake with the timing or having the air fuel at 13 to 1 under boost like I shouldn't have. Mark, I have not tried a VK56 combo. Again, Sling, for your 400 horsepower Honda motor, if it's a turbo H22, you should do 7 thousandths at least per inch of bore. I want to see what awesome idea Johnny K had. And I don't know where it is now. I'm having a hard time finding it. Oh, there we go. An Ecotech bolt pattern. Mountain, I've never tried that. I've never tried that Panavac setup on a turbo deal. We run on the turbo stuff, and this is another thing I had to go through with Finnegan's motor, is that he had the PCV set up with the factory LS3 style valve cover with the PCV in it, and he had a hose going to that, and then he had one going from the other side valve cover, and then he had one coming from the center valley cover, and then he had those going over to like a catch can. And the problem is when we try to run that with a turbo, it was not happy. It needs LS motors need a lot more breather on them. When we run them on the engine dyno, the valve cover that we have that I run on everything that we run on the dyno has just a big open hole that's like about this big, and I have a big fitting and a piece of tubing, and the tubing just goes out to atmosphere, so it's big and long, and it goes back behind the dyno. We want to make sure that we have enough crankcase ventilation on it. And I also don't like drawing the oil vapor into the motor, so I'd rather have it go out if there is any crankcase pressure. But with that setup, there's not. On Mike's motor, we first took the and the other thing that happened when we tried to run the ventilation system, the PCV, the way that he had it with the turbos, when we first started it up, everything like started smoking because it wouldn't allow the turbos to drain, and they're high enough up that we were draining them into the valley cover, so it would not allow them to drain. So we thought, well, okay, we have to readjust this and find out what's going on. So after we opened we took the oil filler cap off, put a rag around it, disconnected the PCV system. In my opinion, even the factory LS, the only thing that helps it out is it's hooked up to the intake manifold, so it draws it in basically. And I just don't like doing that. So have a big PCV hose into like a catch can or something. Yeah, oil piston sprayers are good idea. They're usually more for long-term heat. Yeah, 7 thousandths is good for boosted stuff. For NA stuff, you don't need to go that big. Bam Bam, I hope you did both the top and the second ring. I hope you put ring gap in both of them, because that's what it's going to take. Yeah, max speeding GT45. You got to like the UPS guy when he shows up with one of those. No, Julia's 25 PSI on a 5.4. 32, you're fine. Because that's only like a 3.5-inch bore motor, right? I don't know if Uncle Tony ever responded or not. I don't really think he has anything that he can add to the conversation, because he doesn't understand what dynos can do. Doesn't understand what a chassis dyno can do and what an engine dyno can do. And I don't think that there's, and I'm thinking about doing a video on this with somebody that's much smarter than I am, and that way it'd be Gilligan, which is me, asking the professor what the reality is about some sort of force that I don't understand that could act on the motor that could change the power or performance of the motor without it being measurable by either a chassis dyno or an engine dyno. And I haven't been able to come up with anything where that's possible, unless it's element 115. then that's going to be beyond my understanding. Yes, Bill, I've driven stuff with 30,000 scap in it. My Honda that we set up for Bonneville had probably 7,500 spring gap per inch of bore on the it was less than 2 liters, so it was an 84 millimeter bore. But yeah, and it drove fine, and it didn't smoke. And like I said, I can see all of the blow by on these LS motors on the dyno, so we let them idle and we can drive them around and do all of that. If you feel that that's too much, then put 28 in it or 27 in it. I think that the blow by would come more from the fact that we're using rings, old tired used rings that have 250,000 miles on them, than they would from the extra gap. Every ring gap is a turbo ring gap. That needs to be on a shirt too. Yeah, Kraus, on a marine application, that's also true. Because the thing is, on those applications, even more so than in a car, even in a drag race car, like in a marine application, guys may be at wide open throttle for minutes at a time. And so that's a lot of load, which is another reason the guys with big blocks and stuff like that will run lower compression, with blowers on them. And then you have to add ring gap because you guys are roar all the way across the lake at full throttle. And very rarely, except when they do stuff like I did running the Silver State, are you ever at wide open throttle for even guys that are roll race on the freeway. You're never on the freeway for minutes at a time. Certainly not for 4 or 5 or 6 or 10 minutes, like you can in a boat. So Sean, the factory ring gap specs are 7 to 17 on the top and 17 to 27 on the bottom. See, they're already wanting you to put the ring gap out there for boost. Did somebody ask about ARP rod bolts? An ARP rod bolt on an LS is not really necessary. You're going to break the rod before you have any problem with the fastener. Water injection definitely does help. See, the tall deck big block Chevys have 4 ring pistons, so that if you break one, you have spares. So it works out really good. Nasty, I've never tried the VS Racing mirror image turbos. They look cool, and if they're the same specs as the other ones, they should do what the other ones do. Jeremy, let me know how that T70 works on the Jeep 4-liter. I'm going to run a set of 3076s, and I kind of want to compare them to the 3582s. And what I'd like to do is kind of do a turbo matrix kind of thing. Carb LS stuff works fine. They're a different intake manifold usually, obviously, than the EFI stuff. And so the biggest change really is not going to be the fact that you have a carburetor on it. It's going to be the fact that you have a different kind of intake manifold on there. And lots of guys running around with carb stuff. The carb stuff works very well. Blow through carb stuff works good. Nitrous carb stuff, it all works. LY6 6-liter, those are good. We obviously like those. Jason, yeah, we run vacuum pumps on lots of stuff. Mostly, I think Steve runs those on a lot of things. Mostly big block stuff. James. I don't know if the second ring is gapless in a gapless set. Dave, we've done lots of extrude hone stuff. I haven't done anything recently. I think the last thing I did with them was when I was doing my Engine Masters deal. Unlike most people, they were all running single plane manifolds. I ran a dual plane on mine, on my 410-inch motor, my 410-inch Windsor motor. And I actually had it extrude hone twice because we did it the first time and it picked up a ton of average power production. And the reason for that is that 351 Windsor intake manifold from Edelbrock, the RPM air gap, was not sized for a 410-inch motor that was making the kind of power that we were making with that motor. And so porting it, it really responded to that. So we're like, hey, let's do it some more. And then we picked up again when we ported it again. So that is a good porting system, especially for long runner, hard to reach kind of places. And I like the fact that because it's a viscoelastic polymer, that it follows the path that air does and erodes and builds up pressure and erodes in areas where there are resistance, where there's flow resistance, which is kind of cool. I don't have a lot of experience with an AMC 360. I'd like to test some, so I might be the wrong guy to ask about those. But if you're putting one in a pacer, then yeah, definitely get a 360. Well, Trig, I've never run one. I've never run a Terminator X. I've only run Holly HP. We were supposed to run a Terminator X on Finnegan's motor, but he had the Holly 120-pound injectors, and they weren't compatible. Yeah, Everyday J, I'm excited about the 4200 too. It's going to look cool with the big turbo manifold on and stuff. And after looking at how well the heads respond to porting, that will be cool. The only thing that I'm wondering about is camshafts. We're going to have to do regrind camshafts, but hopefully, if we can get another 20 or 25 degrees of duration out of the camshaft from regrinding it, and we can get the valve geometry worked out with shims and stuff, which I don't think is going to be a big problem. It should work out good. It should respond like every motor does to more camshaft. What do you think of dyno simulators? I like them. They're a good tool. They're anything that you could put in there to find out, hey, what if I did this? What if I did this? And you could spend hours and hours and hours doing them. I don't think you should use them as an absolute thing. I don't think that they tell you what the motor is actually going to do. They're really good for looking at trends. Have you ever bent a connecting rod in a turbo application via engine load and timing? We bent one of the Big Bang rods, but I don't think it probably was power, I'm guessing. And I was surprised, given that it was a Gen 3 rod, that it bent and it didn't break, because I thought for sure it would have snapped. We've bent some rods from hydrolocking, but that doesn't count. Okay, I'm gonna move down farther here. So the other thing that's going on with did I tell you guys about the 4200? We're making a turbo manifold, so I'm ordering a flange for that so that it make life easier for Jason, so he can put the flange on and then make all the fancy turbo stuff from there. So that will look good. It would be kind of cool to have a twin on there, but then it just is more kind of plumbing issues with the twin on there, because then you have to have the right kind of intercooler and stuff. Any spool numbers for a 4.8 862 sloppy stage 2? Yes, take a look at, you're looking for spool numbers on the 4.8 with a sloppy stage 2 and an S475 132. Take a look at the video that I have up where I tested all of the turbos, including the Summit S475 132 on a 4.8. Now, we had the JFR cam, but it's a 224 228 compared to that's a 228 230. It's going to be very similar to that. And we had a stock truck manifold on there, so that should give you a really good idea on spool for that particular turbo. What's the red line on the 4200? I'm thinking it's like 6,000, but I can't swear to that. I don't know that that's true. We hopefully when we put camshaft in it and valve spring and port the head, and especially when I make the Super Richie adjustable intake manifold, we should be able to run it higher than that. What fuel filter you use on the dyno? We have the Aeromotive, the big cartridge fuel filters that we service. Obviously, those guys service those. OC of the 3, did any progress on the Atlas? Did you? I was just talking about the Atlas. I was talking about what we were doing on it. Yeah, Julius, I agree. The twins twins for an inline 6 are complicated, but it does look cool having two of them. Let's see here. My Mustang is tuned for 93, and somebody had installing nitrous kit on my car, put 87, and drove the crap out. Now it knocks when warm. Do you think the damage is? Yeah, you probably did break a piston. I have a low mileage 6-liter. How risky would it be to pull the rods and pistons out and check and change the ring gap and change rod bolts? MPT, don't change the rod bolts. The rod bolts are fine. You don't need to do anything with those. You can keep the bearings that you have in it. You can keep the stock rings in it. Just change the ring gap and put it all back together. I like to clean them, and if I'm really feeling, enthusiastic, I'll take the oil rings out too and just clean that, because a lot of times these motors that have a few 100,000 miles on them, they get a lot of buildup there, and the oil ring wants to not work as well. So if I clean all that out and I just reuse the stock oil rings and stuff, but you don't resize the rod journals, don't do any of that. Just put it back together with the stock. The rod will break way before you'll lose a rod bolt. When you're breaking in a motor, you really have only 20 minutes to seat the rings properly. No, that's not the case. The thing used to be 500 miles. So you're obviously not going to do that in 20 minutes. Would a higher KM engine have a bigger ring gap? What's the KM designation? The final, we don't change rod bearings or main bearings. We don't change any of that from the junkyard motor. We look at them as long as they're okay. If they're scratched up or destroyed or anything, obviously we would change them. But most of them just are worn from being old, but we don't care about that. We just clean them and pour a little bit of oil on them and put them back together. E. Johnson, we're going to try and push a 5.3 again to the breaking point. We did break the other one. We broke the other 5.3. But I don't know when we'll try that again. If I did, I would be interested in doing a Gen 4 version. Half Motorsport, the ring gap thing is always like 28 thousandths or so. No, Thumble, I don't, as I was just saying, I don't use new rings. When we did the Big Bang stuff, we just reused the factory rings. We just changed the gap on the tired used factory rings and put them back in. The 4200 does have variable cam timing, but it's only on the exhaust. And I think that it's primarily used for EGR, but we'll see if we move the cam around and change the power, it'll be interesting. I don't know about the economics of building the 4200 versus the 48. It's really, really big. It's very, very tall, and it's very, very long. When I do these motors, and this is a common misconception when I'm doing all this stuff, like when I pick a Buick or a Cadillac or this 4200 or the K24 or anything, I'm not picking it because it's the best bang for the buck. A lot of guys get wrapped up in that. They're like, yeah, but an LS. I'm like, yeah, we understand that. And if you want to build a motor and not spend a lot of money, make a lot of power, that's a good way to go. But that's not why the reason everybody does the things that they do. That's not the motivation for everything. We want to do things for a lot of people out there want to do things because it's different. They know that it costs more, but they want to do it because it's different. Lifting the hood of every motor in the world and seeing a turbo LS would get boring after a while. So you want to see a turbo rotary or a turbo 2JZ or a 4200 or a Buick 455. There are lots of guys that have Buick 455s, lots of guys that have Cadillacs, lots of guys that have 305 Chevys or 307 Chevys. But all of those things can be made to make more power. That's why I want to do that. I've already shown you what you need to know about making power from a turbo LS. There's lots of guys that are there's plenty of stuff out there. There's no shortage of information on turbo LS stuff, but there is shortage of information on turbo 4200 stuff or how far can we take a stock K24. There's lots of K24 A2 video stuff, but I've never seen one done a big bang like this. There's, and even if there is other information on it, more information is always better. I know, Mike, what's up with that? 327 in, only 90 likes. I'm starting to feel a little hurt. I think I need a hug. The wrecking yard, one of the wrecking yards I normally go to, only because it's convenient for West Tech, is the one in Ontario. Best gap for 1500, 1500 horsepower, 496. That's good. That's a good power level. Look at something in the 7.5 thousandths per inch of bore range, and you'll be good. On the LS3 rod bolts, if I don't use the factory torque sequence, which is easy to look up, a lot of times I'll just go to a predetermined torque value. But I did something interesting, and I'm glad that you brought this up, because I did something interesting previously on another LS where we were tightening the rod bolts, and I wanted to find out how stretchy they are. So I think when we were tightening the rod bolts, if I remember, I want to say that it's like 55 or 56 foot-pounds is kind of where the angle torque thing turns out to be. So we tightened one to like 60, then 65 and 70, and I want to find out. And the difference in the bolt length was measurable, and it was a lot. It was I'm trying to remember off the top of my head. It's been so long since we did that, but it was really, really cool. But I want to say that it was about 20 thousandths difference. It was a lot. When I was measuring it, I'm like, hey, you got to be measuring this wrong. And then I was wondering, well, is the bolt itself, is there something on the end of the bolt that's different on this bolt than on the other ones? And then we measured a couple of others, and sure enough, that bolt had stretched that much more from that torque setting. And obviously that's why they give you a factory setting and a way to do it, to do it properly. But those bolts are kind of stretchy. Goes to 11. I was talking about that earlier. We run a big hose running out of the valve cover, a big opening in the valve cover, and a big hose that runs to the back of the dyno. I like to have lots of crankcase ventilation. I don't know on the L83 Gixxer. I don't know which one of those would be more problematic. My guess is it would be the ring gap, given what we've done with factory rods. That's almost always the first thing. Yeah, on your Chrysler, I would go 7 thousandths per 7 or 7.5 thousandths per inch of bore. That's a really good and on a Chrysler Turbo, if it's a 2.2, that you're gonna turn the boost up. It probably is okay at if the gap if they show a range from 15 to 20, 15 might break, 20 might be okay. That's a big range. That's gonna blow up, and it might be okay kind of range. And you're gonna turn the boost up, and since they were only running 7 pounds on those things, or higher if it was a Turbo 2 deal, but it was intercooled, so in that range it's probably safe. But nobody's gonna stay there. Flamingo, we talked about that earlier, but there doesn't seem to be a correlation between the mileage and the ring gap like you would want there to be. Oh, I have a 200,000 mile motor, so that gap is going to be like 24 or 25. It doesn't work out that way. We've tested some with high mileage on them that have really, really tight ring gaps. The 4200, the way that we're running it with a Megasquirt, does not have a rev limiter on it. But John said that I think it does from the factory. Tim was telling me, that's who it was, that it was 6200 from the factory, but we're not running a factory ECU on it. Julius, we're gonna have to have them reground. I'm gonna have Schneider from San Diego regrind them. Julius, what is that single turbo if it has a GT35 something single turbo on it? What do those things make on the Barra? I had somebody contact me and he said that he had like 35 or 40 Barra engines somewhere. I would assume that they're the NA ones and not the turbo ones. He must be importing them or something. But I like the Barras, and the guys are making millions of horsepower with them. That's actually not that high on my list right now to test one of those. I'm way more excited about the 4200 than I am about running a Barra. We know guys have made crazy power with those, but I'm really excited about the 4200. Richard, you should get a junkyard 2JZGE non-VVTi and test it with different turbo sizes. So what am I going to get that out of? Is that going to be out of a Lexus? Arturo, if you upgrade to anything on the motor, it's not going to pass smog. Alicia, I don't think we've settled the piston flip thing yet. I'll have to test it. Cruddy, on your 402 big luck with a 200 shot, you should have 7 thousandths per inch of bore. Did Sean K-Tech did cams for the 4200? No, Tim, they don't. It's not a weld up and regrind. I think that they're regrinding and changing the base circle. Okay, they're the IS motors for the Lexus. That's what I thought. Gerald, what's up? Thank you very much. Durham, don't worry about the too much volume thing. Julius, but what did those motors make stock? What did that bear? What was it rated at from the factory? Yeah, Calvin said that there's a bad vibration. Mark, the guy who did the harness and stuff for me, was telling me about that too, and I felt that on the 292. They definitely have frequencies. And Tom from the what is it, 12 volt, told me the same thing on the 6-cylinder, that they have a resonance frequency, and you'll be able to tell that it gets unhappy. Would a worn timing chain cause negative pressure? I don't think so. I don't see how. Can having the blow-off valve close at idle on a Vortec cause my inlet air temperatures to get hot? Yeah, you can. You want it circulating while you're under cruise. I watched the Uncle Tony debate about the dyno, and he feels like he's arguing with himself. Like I said, I like Tony, and I had a good time when we did the live thing. What I would like is to do this test and find out whether it works or not. I want something to change. If I go through the trouble of doing this piston replacement and changing the offset on it, and we see something on the dyno, I want to see something. I don't want it to not do anything. I want it to be more or less. I want it to do something, because when you do all that work, you want something to happen. But whatever it is, when we test it, I don't want to, because I feel like now he's just backpedaling and trying to do damage control after I told him that I was going to test it. Then it's like, oh, well, you can't measure it on the dyno. So he's just setting himself up. So if it doesn't work, that now he has an excuse why it didn't work. And I don't care for people doing stuff like that. And I've been wrong a lot, maybe more than I've been right. So if you do something and you think something is going to work, and you tell people that it works and it turns out not to work, the first thing that you should say is, this didn't work. I was wrong. There's nothing wrong with that. If this has been your thing the whole time, and turning the pistons around and find out that it doesn't make any power and it doesn't do any other magic kind of thing that we can't measure, then just say that. Say, hey, look, I've been telling people this for years. We finally got to test it. We found out it didn't work. If that's what happened, if I tested and it makes power, he gets to say, hey, Richard, that's awesome. You tested it makes power. I've been telling people this for years. He gets to be a hero. Either way, you get to win. There's no bad side to that, as long as you have the character to say, hey, look, I was wrong. Don't do this anymore. It's not necessary. That's the thing. You get, it sets you up for the opportunity to demonstrate character, which is always a good thing. You also have the opportunity to come out and be the hero and say, yeah, it's worth 11 horsepower or whatever it turns out to be. So for me, I think testing is always a win-win. William, there's lots of books out there on how to do it. What do I tell people that hate on my small Journal 327? What's wrong with the small Journal 327? Those are awesome motors. Every motor is great. And here's the problem, JD Harvey, is that people have to have whatever thing that they have is the best thing. Oh, this is the best motor ever made. It's not. And you don't even have to tell me which motor we're talking about, because I'll guarantee you that it's not. But it doesn't have to be the best thing ever for it to be good. That's the thing, is and I think social media is partly responsible for this. If you have a 2J Toyota, or if you have a rotary or a Barra or whatever it is, it doesn't have to be the best, coolest, most powerful thing ever. If it works for you and you like it, that's a win. You don't have to convince somebody else that it's better than their thing. It doesn't have to be. That's not a thing. You don't have to compare a turbo rotary to a blown big block. They're different things and they do different things, and both of them are awesome. And that's the example that I always use is there are guys that are, I only like American muscle cars, and the other guys like, I only like JDM, turbo RB motors or whatever. Both of those are amazing, and they can both be amazing. One of them doesn't have to be better than the other. Your 327 is amazing. You like it. It works for you. Doesn't matter what the other guys are saying. Who cares? Yeah, I saw the 318 build. And that's the other thing. Again, the 318 is not the best motor ever made. It's not even close. And the other thing is it doesn't make more power than a 360. And you don't even have to tell me that it's a Dodge. It could be any motor. Just look at what any racing organization. This is the thing that I always bring up when somebody tells me, oh yeah, this little motor makes more than this big motor. I had some guys tell me that about a Honda. Oh, the B16 makes more power than a B18. I'm like, not in any world that we exist in. Oh yeah, it's got a better rod ratio, it likes to rev. I'm like, there's no limit to the RPM of either one of those motors. They can rev forever. But look at any form of racing. If they never put a minimum displacement. It's always a maximum displacement. And every car in the field is going to be running whatever the maximum displacement is. So like in the old Trans Am series, it was a 5-liter displacement. If they would have raised that to a 5.7-liter displacement, there's nobody in that field that would have ran a 302 or a 305 and not a 350, because a 350 will make more power than the 302 or the 305. And the same thing with the 360 and the 318. If you put the same compression and heads and cam and intake and all that stuff on both of those motors, the 360 is going to do better. Okay, we had... Somebody was asking, I think, Julius, Julius, where are you? You were telling me what the stock power outputs were. 270 is 362 horsepower up to 315, which is 400. The 315 is 422 stock. That's pretty sporty. Let's see, the final, I noticed a difference with MPFI spraying the back of the intake valve as it opens versus SFI spraying past the open valve in the GM. So how is multi-port fuel injection versus sequential fuel injection? That's what SFI is, right? Or am I missing something? There's going to be a difference in charge cooling from where you inject the fuel. So if you inject it at the top, like a carburetor or a throttle body injection versus port, the other one will have more charge cooling. Injecting it, so I don't know if you're injecting it. I don't know how you inject it past the valve. If you inject it on the other side of the valve, like port or like direct injection, I understand that. Maybe I'm missing what's going on there. Maybe elaborate, expand. Yeah, I like the transition thing. I'm like, have you ever been on a chassis dyno? I mean, we could sit there on a chassis dyno with the thing idling away and spinning the roller and just nail the throttle, and that will do transition, and it will go through any RPM range, and it will do all the things that you want. And if you make a change and it hits the converter harder on the chassis dyno, we'll register that as torque or horsepower. I would be very interested to see some tests with no intercool and running water meth to see what power differences. Did you see the water meth test that we did for Engine Masters? We did intercooled, non-intercooled, and water meth. So exactly, I think what you're wanting to see. When is the next Vortec 4200? After we run it on the dyno. Half Motorsports. I do want to test the quad 4. There was one in the wrecking yard that I really wanted. I've run some stuff on a 3400. We do want to run stuff on a North Star if I can get that bell housing. And there's a lot of those motors that share that bell housing. Then we can run those, assuming that we can get the fuel injection working. Richard, what are your thoughts on a G8 1,000 horsepower to the ground build? Do we need a Radium Engineering fuel pulse dampener direct mount kits? I'm lost on that. Yeah, the resonance that you're seeing in there is not caused by the ignition. Does compression ratio make a huge difference with a turbo, less noticeable than a natural aspirated motor? It does exactly the same thing. So if you change the compression from 8 to 1 to 9 to 1, it will make more power, and then the turbo will be more responsive and all that. It'll do the same thing. But the gain that you get is a percentage of the NA power, not a percentage of the turbo power. So it's 3 to 4% gain per point of compression of the NA power, whether it's on a turbo motor or not. The bell housing on the North Star is a big problem. It can't be too much of a problem because we saw a lot of North Stars running in the sand rails. So people obviously have that figured out. Sean says that the 4200s were not balanced like other GM engines. Stuffed crust or regular pizza. There, in my opinion, there's no bad pizza. In the 4200s, I'm told by Mark that they changed the counterweight of the crank. The 05 stuff has a fully counterweighted crank, and then in 06 they went away from that. So what he wants me to do is get the fully counterweighted crank and build up one of these motors with a fully counterweighted crank, and then forged rods and forged pistons and a ported head and cams, and then instead of putting this size turbo on it, we put this size turbo on it. Scott, how much boost can we run on an LQ4 with a 475? Look at the Big Bang. Look at the videos I have up. We ran a stock bottom end with 2 of those S475s, and it made on a Gen 3, it made 1480, and on the Gen 5 or Gen 4, it made 1500. So you can, if you only have one S475, that's about 1,000 horsepower. You can do that on an LQ4. I would put ring gap in it, put springs, put a cam, and then away you go. What's a tolerable compression ratio for pump gas? Are you running boost on that? And the compression and the octane or the detonation threshold are not the only things that you need to look at. There are lots of other things that determine what the detonation threshold is. Yeah, the final, I ran one of those 4.3 Vortex. We ran one that had the counterweight on it, and it was a 200 horsepower NA motor, and it worked really well. We ran one with a turbo, and we ran one with a centrifugal blower, a torque storm. Yeah, the head interchanges, Tim. So you could run the head on the 06 and up is better than the 05. So you apparently, according to Mark, port that head, but you want the crank from the 05. No, we don't do anything to oil ring. Just make sure that there's the minimum gap that they recommend, which is just make sure that there's 15 to 20 thousandths on the ring gap. Dylan, what is the difference that you're seeing between what and what? Reusing those bolts, I was just talking about the rod bolts were very stretchy, and I don't like, and although we've done it a lot, we've done it a lot on the head bolts too. I haven't reused the stock head bolts and used them under boost, although I know that you can, because I know Matt's done it. But I like that's one of the things, like I would spend money on a wastegate, on a good wastegate, and I also spend money on the head studs. I would put ARP stuff in it. I think that there are books on tuning Holley EFI, but they also have classes for that. How does the compression ratio affect the turbo? It will affect turbo response rate because the motor makes more NA power if you change the compression ratio. If you change the compression ratio, you're going to make more torque. You're going to make more horsepower too. That's just a function of RPM. But if you increase the torque by, let's see, 4% on 400. So if you increase the torque by 16 foot-pounds, that's going to affect the spool rate of the turbo. What gap would you recommend for a stock bottom end heads cam intake 403 with a 100 shot? I've run 100 shots on stock unopened 302s a lot. I probably ran 20 or 30 bottles full on my 88 Mustang. Never even knew about ring gap. I mean, I knew what ring gap was, but we never put any more in it. We didn't take it apart. That thing was brand new, so we just put more and more nitrous in it. But 100 shot was easy. You don't have to do anything for 100 shot. We haven't run the 3800 yet, so no turbo on that yet. 2.5 minutes. I'm cutting it off at 1 hour. Frank, I don't know. Are there different mega squirts? I'll have to find out which version it is. Yes, Dyno, you can. You can take the pistons out, put ring gap in it. We don't hone it. We just put it back in. And I've also taken the piston rings out, gapped the factory rings, the used tired factory rings, and ball honed it, and then put it back in, and it still worked just fine. Yeah, we weren't. I wasn't talking about being the 06 being balanced. I was talking about counterweighted. The design of the crank is differently. A 2.5 inch hot side's fine for your 5.3 with the GT45. In fact, I think we run a 2.5 inch Y pipe off of our stock exhaust manifolds, and we've run, way into 4-digit power levels. Is there a good book for LS builds that we can follow? Well, I have a couple of LS books out. 3 of them, I think. No, two LS books. Have you ever found the need to O-ring the header block on LS engines? I never have, not at the power levels that I've run. You know, guys are obviously doing a lot more than that, so maybe that becomes necessary, but not at the 1500 horsepower that we were running. How much more gap do you need for every 100 shot? If you're going to do more than 100 shot, if you're going to 200 and 300, then just put 7 to 7.5 thousandths per inch of bore. Okay, guys, I got to get going. Yay! Another successful live feed. I've got more videos coming up. I've got to work on, a bunch of stuff I'm working on. We obviously had lots of testing down there at West Tech. And so I've got to put together some videos. I got to get more stuff up. Thanks for watching, guys. I will see you tomorrow.